Hello and welcome to Module 3, the Hardened I2C Interface. My name is Dave Baldwin and I am a Field Applications Engineer for Lattice Semiconductor. I will be describing a reference design and demonstration design for the Hardened I2C Interface on the MachXO2 programmable logic family. Chris West will be walking you through the actual demo design. This module on the I2C interface will consist of 3 parts, a reference design and 2 demo designs. As a user may note from the slide, the 2 demo designs differ in that one is based on logic gates in RTL and the other is software based in the C programming language. Now let's take a look at the reference design, and later Chris will walk you through both of the demo designs. So, reference design 1124 provides an easy to use RTL code that can quickly allow the user to implement the I2C slave interface with minimal effort or need to learn the intricacies of the embedded function blocks, the wishbone interface, or even the I2C protocol. The reference design can be used as an I/O expander for a pin-limited micro, or attach the MachXO2 to an I2C bus as a master and access the fabric. The example allows data access from logic or from memory locations. As with Lattice's other reference designs, there are customizable aspects of the user portion of the RTL code. This and the I2C command set is fully described in the reference design documentation. Next, we will take a look at the 2 demonstration designs. The first of the demo designs used in the I2C User's Guide, UG55, uses a remote display and memory to illustrate the workings of the bus. It allows the designer to control both ends of the I2C interface. The software design files contain a UART, a CapSense, and LCD interfaces, as well as customizable aspects of the I2C interface. So this slide shows an overview of the hardware and software requirements for the demo, a picture of the demo boards connected, and a screenshot of the hyperterminal window with the LCD display. All the demo operations are described in the user's guide, as well as fully commented code. Chris will be demoing this next for you.
Thanks, Dave. And now we'll be going over Usage Guide 55, the I2C Master Slave demo. So once you unzip your zip file from the website, you're going to see a bitstream folder, which includes the JEDEC files for both your MachXO2 Pico boards. There's a documentation folder, which includes all the relevant documentation. And then you're going to see the diamond projects for the master and for the slave board. First, let's start off by programming up our boards. For that, we'll use the Diamond Programmer. And first, let's start off by going to File Name, and we'll select the I2C master.jedec file. And make sure you have your board powered up. And we're going to click Program. All right, next, let's program up our slave board. So select our slave JEDEC file. All right, let's power up our slave board. Click Program. All right, so now we have both boards that are programmed. So let's come over here to our boards. What we're going to need to do, we're going to need to make our connections. So these will be your I2C connections, and we'll have our ground connection here. For these connections, you can refer to the usage guide for the pinouts on the header. So first, let's just power up our boards. All right, so what we can do now from the master board, push 1. We can see 1 is displayed on both of the boards. 2 will be displayed on both of the boards. Push 3. And we will be sending data from the master over to the slave, 8 bytes of data. Push button 4, and we're going to be reading the data from the slave back to the master. All right. The other thing that we can do with this demo is we can connect to it using hyperterminal or any terminal program. So for this project, I'm going to use hyperterminal. You're going to be asked to connect using a COM port. For that, you can use your device manager. Go in there and you'll find out which COM you're using for your master. For me, I'm using COM 55. For your bits per second, just change that over to 115K. And your flow control, just set that to none. Now you'll be connected. Next thing you want to do is come over to the master board and hit your S1. This will load up the menu. You can push 0 through 9, and you're going to update the LCD with the numeric characters. You push W, and this is going to write 8 bytes of data over to the I2C slave. And you push R, and this is going to read the 8 bytes of data from the I2C slave. All right, and that's it for Usage Guide 55, and I'll hand it back to you, Dave.
Thank you, Chris. User's Guide 54 is a bit different in that the I2C and SPI bus interfaces are software defined rather than hardware configured. It is based upon the soft IP core, the MachXO2, and includes code written in the C programming language that can be modified by the designer. The other modules included is a UART, an LCD port, and a wishbone pass-through interface. This allows the designer to write directly to the LCD without the need for a MachXO2 in the second board. So this slide gives an overview of the operation, hardware, and software requirements for the demo in User's Guide 54. The demo used in this guide is a simple temperature sensing program that will allow the designer to look at various aspects of the SPI and I2C bus. It will also give a brief use model of the MachXO2 environment and interfacing it to sensors and a display. It is fully documented in the user's guide, and Chris will be walking through this demo for you now.
Thanks, Dave, and let's review Usage Guide 54, the MachXO2 Ecosystem Builder in C. So once you unzip the file from the website, you're going to see the following folders. There's the bitstream file, which includes the JEDEC file for the MachXO2. There's a docs folder, which gives you all the relevant documentation. The hardware, which is the Diamond project and all the demos in there. The software, which includes the Ecosystem Builder, all the files. And then there's a workspace. This is where you would save your Ecosystem Builder project. All right, so let's start off by programming the MachXO2 with the demo. So what we'll do is we'll come over here. We're going to go into the bitstreams folder. We're going to select the JEDEC file. And we're going to program the board. All right, and what you can see on the LCD, now that we've programmed the board, is the temperature that is being displayed. Okay. The temperature sensor is actually right here, so if you put your finger on it, you can see the temperature change up and down. And let's do this. We're going to go over to Hyperterminal, or any program that you have for the terminal, and we're going to connect to the MachXO2. The COM port that I'm using is COM55, but if you need to know yours, you can go into the control panel system, and you can find out the COM port you're using. Bits per second, we'll change it up to 115K. Flow control, we'll set that over to none. Now that we've connected, you can see that the temperature is continuing to be red. Push any key, and the menu will be displayed. So the couple options that we have are precision. We can change from 9-bit all the way up to 12-bit precision by pushing P multiple times. Okay. You can push T, and this will just continually get the temperature. You can see I'm using the 12-bit precision. And this is getting it from the I2C temperature sensor. If we push L for log, this will actually get back to the menu, push it again, and we're going to start logging all the data to the SPI flash memory. Push another key to get back to the menu, and then push R. We're going to recall, or we're going to read all the temperatures from the SPI flash memory. So that's it for Usage Guide 54, and back to you, Dave.
Thank you, Chris, and this will conclude Module 3. Thank you, audience, for your time, and could you please take a moment to fill out the online evaluation form shown on this slide.